In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Asteroid 30 here yet again, and welcome back to the whiteboard. Now, today, as the title suggests, I want to look at a plus minus 15 volt regulated power supply to power op amps, or a preamplifier in this case. And I'm going to use an old true method that's been used for years. I'm going to use an LM317T for the positive one and an LM337T respectively for the negative going rail. Now, the reason for this, I'm using variable voltage regulators, is because this resistor R2 here and here can be adjusted to whatever value you want to get, either slightly higher or slightly lower supply rails than plus minus 15. So you could make it plus minus 17 if you wanted to. So let's just look at the positive going side here for a second. Now, this runs on a bipolar supply. So we've got the VCC, or the positive voltage, coming in off of the power supply, main power supply, say the main filter caps of a power amplifier. And in this case, the LM317T has a maximum input voltage of 40 volts. So you've got to keep that in mind. So the supply rails coming in can't be any higher than plus minus 38 volts. That's fine. Now, we'll notice that we've got two diodes, one here and one here. Now, what this diode does here is if you're using a capacitor here on the output, which I am, it stops this capacitor from discharging back through the regulator. Instead, it discharges back to its input. So it can stop the problem of, if this capacitor was to discharge to the regulator, of actually damaging the output stage. So the data sheet recommends that you use one if you're using an output capacitor. This diode on the output here is a flyback diode, so that whatever load is connected to it suddenly is discharging back through the regulator, for instance. Then it gives it a discharge path to ground rather than back through the regulator. That's all that's there for. Now, to calculate your voltage output, you can use either one of these two calculations for both the positive and the negative regulators. R1 in this case is a 240 ohm resistor which goes between pin 2 and pin 1 of the ICs. So if you know what the value of resistors are, you can calculate what the output voltage is going to be by using 1.25, which is the reference voltage and the minimum that the regulator can go down to, multiplied by 1 plus R2 divided by R1. And that will give you what the output voltage would be with these two resistor values. Or, if you want to know what the resistor value of R2 should be for a specific output voltage, you can go R2 equals R1 multiplied by the voltage output that you want, divided by the reference voltage of 1.25 minus 1. And that will give you your resistor value for R2 in whole ohms. Then you would just round up that value to the nearest available resistance. And you may end up with a slightly higher output voltage if, say, your resistor value was something stupid like 2380 ohms, which is not really an available resistance value. So you'd go like, 2.5k or something. So that's it in a nutshell. It's a very simple circuit. There's not much really to discuss about it. You could make R2 an adjustable potentiometer, say a trim pot. So you can actually specifically set this pot, say a 10k, to whatever output voltages you want. So you can have plus minus 16.5 volt, for instance. That's an option. However, I've calculated it based on using 240 ohm resistors here on the adjust pin and output, and 2K7 is roughly about right for about 15.3 volts on the output. So what we're going to do now is I'm going to build this up on a breadboard, and I'm going to test this. Because I went to JCar yesterday and I got some parts. I got 3 regulators. I got 2 LM317Ts because I want actually a plus 12 volt rail as well. But I may or may not include that on the main breadboard when I breadboard it up. There's no point. It's the same as the positive side 15 volt regulator. It's just a different resistor value. I set it to get 12 volts at 2K2, I believe it was. Anyhow, I can always use the built 15 volt side to test that output voltage with a different resistor. So I don't really need to put the third regulator on there, but I can if I want. Alright, so I've got the circuit built up on the breadboard, and I forgot one major aspect about the negative voltage regulator, the LM337T, or LM337. Pin 2 and pin 3 are reversed on the negative regulator. So in this case, pin 2 is the input and pin 3 is the output, whereas the 317 pin 2 is the output and pin 3 is the input. So these are backwards. So I had it configured the same way as this side, and I was getting like 18 volts coming out of it on my positive 18 volts coming out of it on my DC bench supply, which is the maximum voltage the supply goes to. I'm like, what's going on here? And so I played around with some resistor values. I changed the 240 ohm to a 120 ohm, and I could smell resistors cooking, and it actually started destroying this resistor. So yeah, it didn't destroy the IC though. So yeah, just keep that in mind when building up this circuit, that the pins 2 and pin 3 are reversed compared to the positive regulator on the negative regulator. I'll update the schematic that I've drawn on the whiteboard, and show it again at the end of the video. So with my power, So with my power supply set to roughly plus minus 18 volts, so there's 18 volts per side, thereabouts, 19, close enough. I'll turn the supply on. The multimeter is connected between the positive output and the negative output, and we should see 30 volts there. And we do, 30.6. So it's a roughly 15.3 volts per side. So now if I move my negative probe of my multimeter to the ground point, and now we're measuring off the positive regulator, we can see we've got roughly 15.4 volt there. So now if I move my positive probe to the negative output, as we can see we've got a little less, minus 15.2. It's not exactly balanced, but that's going on the tolerance of, the components. So I want to load test this now, so I'm going to put my multimeter probe back on the positive output and put my negative on the negative output, so we're seeing the full 30 volts. And I've got this 330 ohm 5 watt resistor here off to the left, and I'll take it from off ground. I'll put it from negative directly across to positive. And according to the power supply, it's around about between 70 to 100 mA, which is about right. And we can see that, well, the voltage hasn't decreased much. So if I take the load off, hardly any change. Put the load back on, no change. And the supply is still saying around about, the 70 to 100 mark. Those meters aren't really accurate, but that is right, because 330 ohms across a 30 volt rail is going to dissipate about 90 mA through the resistor. So that works great, and these heat sinks aren't even getting hot. I'll just check my resistors. They're not getting hot either. So they're fine. Great. So, well, that's the plus minus 15 volt side. I don't really have enough room to set up the 12 volt side because it was hard enough setting up this side. I don't really need to, but if I was to play with this set resistor here and put a 2K2 there instead, it should drop the voltage down to 12. So I'll turn the power supply off and I'll just check that. I'll just change this to a 2K2 from a 2K7 and we'll measure the output on the positive going regulator. Pop that one out. Pop the 2K2 in between pin 1 and ground. And I'll disconnect my load. And I'll also move my negative probe to ground, which has now disconnected itself. Anywhere's a good ground, I suppose. There we go. So I'm going to leave the power supply set to the same input voltage, and now I'm going to turn the load on. Look at that, 12.7 volts. Probably a little high, probably 1K8 would bring it down a bit. It is what it is. I suppose 2.7 is fine. Now I'm going to load this with a relay, because this is what it's going to eventually be powering. I'll explain before I close the video out of what I'm doing here. So I'll go between ground and the positive output, and the relay turned on as the voltage did not drop down. That's about 44 mA on that. So that's fine. Perfect. Alright. And there's the fixed up schematic there. I've reversed the pin numbers around on the 337. Now those of you that were probably watching the intro of this video and have worked with these particular regulator ICs before would probably have realised my error. It works, and it works fine as long as you get the thing wired the correct way around. So why am I doing this plus minus 15 and a 12 volt rail? Well, I did make up a PCB using some series pass regulators and xenodiodes to do the same thing for a amplifier project I'm working on to power a preamplifier on the plus minus 15 volt rails and the 12 volt rail to power a bunch of relays like input switching and stuff. And it didn't work out so great. I even had the PCB made and it just didn't work. And that's the PCB there. There is a video on this. It was a failure. I still uploaded it as a video because, well, yeah, you might as well see the failures. So that's why I opted for the tried and true method by using linear regulator ICs. It does the job well. And as my supply rails aren't any higher than about plus minus 36 volt, this solution works fine. Now, having said that, what I'm going to do now is I'm going to hook it up to the power supply that is eventually going to be powering it and run it off of a transformer and see how well it actually performs. What I'll do is I'll change this resistor back to the original one so it's not giving a weird 12.7 volt output and wondering why. Alrighty, the breadboard is now connected up to my amplifier power supply and protection module that I built the other day. I'm going through a JST connector. This is how it's going to be in situ inside of a unit. So it was a good idea that I tested the breadboard circuit on the DC power supply first, because having this backwards means basically shorting the IC out potentially and actually destroying it. So it's a good job I didn't put 35 volts up its arse. So this will either work or it'll blow up. Now I've got the multimeter currently across only one side, so I'll put it across both so we can see, if we've got plus 30 odd volt there. I can't even talk at the moment, don't know why. Turn it on. Voila, 30.69 volt DC. So to finalise this, I'm going to load the circuit down again with that 330 ohm resistor. Also find some leads to do it with. One minute. Okay, so one gets connected to positive and one side gets connected to negative. No change, still 30.6 volt. Excellent. There we have it there. It works. I knew it would. I've built this circuit before. I just never went through it in depth before. So yeah, no, that works. I have actually modified that PCB that I showed you before to actually accept these regulators. Although I had it routed with pin 3 and pin 2 the other way round as I had it set up initially, and it didn't work. So I've now corrected that on the PCB, so it's the correct way around, and this resistor is useless. So anyway, I'm going to end this video here because I've just proved what I wanted to prove today. It works, and it works great. And in my PCB I do have bulk filtering up here and 10 microfarad capacitors on the output. Yeah, and nothing's gone off with a bang, so everything's good. So if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And I will catch you in the next one. This is the Astro 30 saying, see ya, have a great day.